Hello and welcome to today's PowerVug session. This is Jyoti Dodia and I'm really pleased to have with us Nigel Griffiths and Gareth Coates, who have been working on a newly announced IBM Power9 server called the IC922. So today's session is all about that server. So without further ado, let me hand over to Nigel and Gareth to introduce themselves, and then we'll kick off the session. Thank you.
Hi there, I'm Nigel Griffiths. I work in Advanced Technology Support in Power Systems for Europe, and we've had one of these machines for a little while now, so we're pleased to introduce that new machine into the world. We do lots of product introductions, and then we speak at conferences and do technical support as well. Gareth, explain what you do.
Well, yes, I'm the other half of the team. I'm Nigel, and I complement each other. Nigel's, some of you might know, he's got a bit of a hobby is Nmon and things like that, so he's great on the deep operating systems side of things. I'm sort of hotter on the hardware and the firmware, and we work together to support AIX, Power, Linux, and the hardware.
Okay, so we're pleased to introduce you to the IC922, which is a bit of a mouthful. I tend to say ICE922, but that's another question. Here we have the picture of the little machine, and on the left-hand side we have Nmon monitoring the high-performance graphical engines that we can put into the back of this machine, the NVIDIA GPUs. We'll come to that in a minute. So this is our contents page end up in here, but this is one page of marketing. There's another 3 pages later on. I'll go through those quickly. So we have the AC922 that's been actually out a long time now. I think it's approaching 2 years. And that's very good for the guys that are interested in artificial intelligence and high-performance computing. They can use those GPUs to do intense mathematics on modeling and things. But we also find that when you go into production, rather than developing the models, you just want to use the rules that it created to actually check, is this image a cat, for example, or something like that. So that's a lesser workload, and you don't really need the power of an AC922 to do that. So this is where one of the use cases for the IC922 comes in. So we have a reduced price for when you go into production with your artificial intelligence solution. This is a busy chart, and we'll probably copy these links into the website later on. We announced it last week, 28th of January, and it's generally available Friday. So get your orders in quick, and you get one by next week. I did note, I didn't realize this when I created this slide, that there are 13 countries that will get the GA date 6 weeks later. A lot of little countries that, quite honestly, I couldn't put a pin in the world map of where they are, but the larger ones are Russia, Mexico, Taiwan, South Korea, and Ukraine. Also find that there's a later GA date for India, and IBM has not been selling this computer in China. I don't understand what's going on there. Maybe there's another way of people buying it in China. We already have 2 little YouTube videos, 10 minutes of first look flying around the machine with a camera, and the fast facts. We're going to cover the deep facts here in this session. You can see the announcement links there, typical IBM ghastly URLs. And we have the manual pages are now available. That was actually on the announcement day they became available. That's the landing page. That's the top one. You can drill down there to find out all the information. So let us look at a couple of pictures. I've actually hidden a whole bunch of these because Gareth's got all the pictures in his deck here later on. But here it is. Here's the picture of a new machine. If in early pictures you see that those little handles that release the disk there were terracotta, a sort of orangey color. They are actually blue in the real machine, so watch out for that in some pictures. Briefly at the top we have some usual power buttons and LEDs. 24 2.5-inch drives. That's quite a lot of drives for a 2U machine. In here then we have 6 fans. We have lots of DIMM slots, 32 of those. That's quite a high number as well for a 2U machine. 2 power processors. We have at the back, there's some upright low profile slots for your adapters, and some are in sideways for the bigger adapters. Then we have 2 power supplies in the corner. So we're going to dodge the rest of the pictures. Oh, there's one more picture. You can either have disks, or if you take the disks out, you'll find that you actually have 3 bays, and if you haven't got the bay guts, if you like, in here, then you have these fillers to cover up the holes, and so you can go from 0 disk to 24 disk, anywhere in between. You can actually get that sorted out for you. Around the back of the machine, I'm just going to highlight the fact we have 10 PCIe slots. So 1 and 2 are the low profile, and 3, 4, 5 are the full height, and then the same again is duplicated up to slot 10. Gareth's going to cover the rest of the details on that slide. So let's move on to some use cases. Then we'll use the what I call my bluffer's guide to what inferencing is all about. Then we'll look at, we actually made 1 or 2 sales already, and then we got the 1-page overview before we go into the details. So what is this computer aimed at? Well, primarily is for this GPU inferencing artificial intelligence, and high-performance workloads can benefit from those GPUs as well. At the moment, we have 6 GPUs. They're actually on adapters, unlike the IC922, which are built into the planar of the machine. And there's a statement of direction that we're actually going to go to 8. 2 terabytes of memory, that's quite big. Then we've got 40 Power9 CPU cores with SMT4. And this is the idea that we've already talked about, inferencing partner for the IC922. But if you haven't got GPUs, as I said earlier, it's pretty good. High density for storage, 24 internal disks. In my video, I accidentally said 92 petabytes. I actually meant 92 terabytes of size. A lot of people thought that was very funny and got back to me, but we corrected the YouTube video. And these are supporting irregular disks and SSDs at the moment. There's a statement of direction for NVMe drives. And if you're not that interested in putting it full of disks and just using it as a storage server, well, you can still use it for regular cloud work. So as a cloud, perhaps running RHEL, Red Hat OpenShift for lots of flexibility for its Kubernetics and those other workloads, Dockers and containers and all that. Or you can use it as a generic Linux on Power and KVM. There's a little note at the bottom here that KVM support is actually due at a later date. We're talking months rather than years for that. The developers think it probably worked fine, but they haven't gone through the test cycle for that yet. So you may want to hold off for a couple of months if that's what you're particularly interested in. So a good set of workloads in there for the machine, depending on what you want to do with it. You could, of course, do a mixture of those things. You could use have some data and having the GPUs to do the artificial intelligence. So here's my bluffer's guide then. As I was saying before we started, just as a warm-up, when you're training an artificial intelligence workload, then you're presenting, perhaps this little example, it says cats and dogs, so lots of pictures, I mean thousands of pictures of cats, and it, by the magic of AI, is working out the rules itself on how it can determine whether this picture is a dog or a cat. And it's producing, if you like, billions and billions of rules, discounting ones that don't seem to make any difference to getting a better result, working out the set of rules that it can actually use to actually get a very high accuracy with determining what it's looking at. And this could be videos or soundtracks or telephone calls or whatever it is you're trying to analyze. This typically takes hours and hours and hours working on a model. The data scientists are tuning what they're looking at. Perhaps they say that it's working cats out well, but it's getting confused with I don't know, concrete statues of cats. And so it can say, okay, we can show it a whole bunch of statues of cats saying these are not cats, and then it can refine the rules to actually get a better prediction of the results. And you end up with this trained model. But when you go into production, you're starting to use this. Well, cat isn't perhaps a good example, but maybe it's you're looking at pictures of car accidents and trying to work out how bad the damage is on the car, for example, as more sort of a working example. But you've got 1 or 2 pictures. You want to say, is that a cat? And so it's using the rules and just applying it to this one picture now to determine if it is or not matching the model. So that's a much lighter workload. Now, typically, if you've got users involved, then you actually want sub-second response. You don't want the users waiting an hour while it sorts it out. It's actually responding in a second for each particular image that is presented. And you may have 500 people on a help desk using this as a service to help them do their job. So we don't really want, when we're doing this inference, to actually use the same computers that we are using for generating, training, and developing the model. So this is where the IC922 comes in as a low-cost point to run into production. So in the middle here we have the training, the AC922, and then the reduced price for the IC922 can be used for inferencing. You could also, as we said, we can put 92 terabytes of data in this machine as well. So we could actually use it over here without GPUs, just using it as a data server. Or we could actually do a mixture of things on one machine. Over here we have some of the software that's available on the two machines architectures over here with the two different GPUs in them. And in the middle and here, perhaps you don't want a big cluster of these machines working on massive models, pictures with very, very high resolution. Maybe you just want to have a little project you run before you actually commit to a bigger machine. So you could use a single IC922 to do some of the training. It will be slower, but it will get it done. And then you could use it for the inferencing, and perhaps you've got the data on your board as well, so you don't have to ship the data in and out of the machine. So this is a good idea of a low-cost DIY sort of solution in here. And of course, we can do inferencing on our big machines using the main CPUs. That's a fairly expensive way of using the Power9 CPUs. Also, at the moment we're looking at the GPUs being put into the machine. You see here that the GPUs, it's called a T4 from NVIDIA. It says 70 watts in here. If you're using an AC92, then the V100s are taking 300 watts. It's quite a hungry engine for the amount of electricity it uses. So this is, again, allows us to put more of them into a single machine. There is in the statement of directions that FPGAs and ASICs devices will be supported as well and a later general availability. This is, we kept this rather secret. It was announced, but we never said what the computer was in here. The US Army has bought $12 million worth of these now called IC922s. And these big sales that happened before we actually produced the product to release generally actually funded a lot of the development costs of the machine anyway. So that's already a success before anybody knew that it was actually going to be available. And here's my one-pager, so the summary chart. Maybe I'll print that out and keep it in your wallet. Show I don't know, the mother-in-law next time you see her. I'm going to cover all of these facts over here on the right, on the left-hand side. Yeah, all of these. The native I/O, Gareth can show you pictures of those. I don't really cover the Red Hat. The operating system supported at this one first GA is Red Hat 6.7. That's it. There's a version that you download called ALT, A-L-T, and that's the one you need for the Power9 support. And we're going to cover most of these things. We've got the RAS in here, so I think Gareth's going to cover those as well. Right, I'll move on. Here's our statement of direction. Actually came out in the announcement. I gave you the links on the second slide where to get the announcements. In that there is the statement of direction, and I've paraphrased it and reduced it for a lower number of letters. So we have this 8 accelerated devices. We have the 6 NVIDIA T4s at the moment. They're going to add, as an alternative to hard disks and SSDs, solid-state drives, the NVMe drives for speed at a later date, and we're going to open up the OpenCAPI technology, so other adapters that use that to produce very high bandwidth. So the adapters will be available there. It's built into the machine now. It just hasn't been made supported yet, so we need more time to do the testing for that. So into the details. Right, we have a choice of 3 different CPUs. Ignore the rest of these. What you really need to know is the entire server has 24, 32, or 40 CPU cores. We don't have an option for having one Power9. It's always 2 Power9 chips in the 2 Power9 sockets. And of course, we're using SMT4 in these open power machines, so it's SMT1, 2, or 4, and we're running at 3.8 gigahertz. If you go for the 16 CPU cores, then we can tweak it up to 4 gigahertz. Now, the price per core is about the same, so you just pay a little bit more as you want more cores in the machine. You may have a workload where you decide perhaps you don't need all 40 cores, so there's no point having them. You can reduce the price by a couple of thousand euro, dollar, pounds, so have the less numbers of Power9 cores in your server. A lot of words on this one with the memory. But ignore all the words. We have the DIMMs come in 16, 32, or 64 gigabytes each, and you can only have them in sets of 4, 8, 12, 16, 24, and 32. So these combinations here in purple, they are the only options you have. That's what all those rules down below are telling you. So you have to decide how much you want, and then you're going to try and find it on the chart. There's a little hint here about recommended. If you need the biggest amount of memory in here, then you best to go to using all 32 DIMM slots. If you don't need all 32, because of your requirements, then 16 is a good number to aim at, because that will use the maximum bandwidth to your memory, or from your memory. If you're going for between 4 and 16 DIMMs, then it's running at the 2666 gigabits per second, and if you're above that, it goes slightly slower. It's operating in dual or double drop mode. So the memory channels are going to 2 DIMMs instead of 1. So we have to run it at a slightly lower speed to do that, to get to the higher amounts of memory. I've got these little stars on these ones up in here. If you decide you need 512, then you could buy 32 of the small ones, 16 of the middle size, and 8 of the larger DIMMs. And I would recommend this one in here. That gives you the maximum memory performance, but you still have a possibility of doing an upgrade. Now, we've looked at these prices. I've given presentations in the past saying the largest memory DIMM sizes come at a price premium because they're harder to make and the manufacturers want you to pay more for them. But there are 128 gigabyte and even larger DIMMs available. We're not using those in here, so the price per gigabyte is just about the same for all of these DIMMs that we have in this machine. If you need 128 gigabyte DIMMs because you want to get up to the 4 terabytes or 4,000 gigabytes, do let us know. We're looking for an excuse to do that in development and get that tested as well. The developers tell me they just need to be fitted and tested. Now, actually placing this machine is because there's a limited numbers of options of your DIMMs. Then you find out how many DIMMs you've got, and this chart in here tells you exactly where to place them. So if you only got 4 DIMMs, then you'd look down here 0 to 15, 16 to 31, and if you've got 4 DIMMs, they go in 5, 21, 13, and 29. That's it. They just pop in. This chart is actually on the machine. Gareth will show us the pictures of exactly where that is on the at the air dam inside the machine. So it's not rocket science. It's pretty clear, and it's actually documented inside the machine. So that doesn't need much of a further discussion. On the power supply side, we have 2 power supplies. This is 1+1, so if one power supply goes bad, then it will just carry on running, and we can replace it with another one. And I'm pretty sure you can start the machine on 1 power supply if you really need to. If you're on 1 power supply, of course, you're stressing out that power supply. That makes it less efficient. It probably whack the fan speeds up as well. You really need to have the 2 power supplies, and we're not selling you these machines with just 1 power supply. There is a cable management arm, or some technical people call it CMAs. This is recommended. It will be put into the configuration unless you take it out. We actually haven't seen one of these. We've had an early ship machine, so we would like to actually see these. But that means you don't have to disconnect the cables if you want to pull the machine out on its rails to do things inside the machine. Gareth will cover later on about what's actually removable from the machine when it's running, and then if you power it off, then what is removable from the machine when you've got it pulled out on the rails and the lid off. Oh, there's a good point there on that last slide. Can I go backwards? I can. Yes, the rails actually allow round and square hole racks. Whoa, this is real state-of-the-art technology. We complain quite a lot that we don't support both. Okay, if we look round to the storage side of things, then we've already talked about the 3 bays with 8 drives in each. They could be SAS or SATA, hard disks, spinning disks, or the solid-state drives in here. And you decide how many of these bays you want to activate it and how many disks you want in them. Now, there's no built-in storage adapter inside the machine as a daughter board or on the planer at all. So if you want any disks in here, you have to buy HPA, a disk controller that will sit in an adapter slot. So there's a couple of options in here. They tend to be quite well-known adapters in the industry anyway. We can actually look at the part numbers in here and look at the Broadcom website for the details if you want. The first one supports 8 drives, the second one supports 16 drives. The third one, the 47, supports 8 drives, but it includes Mega RAID with a 2 GB cache. That will be another little daughter card you have to put in the machine with the battery for the caches. And if you buy the EKWD, then you can switch on the self-encrypting feature so that if somebody walks down your computer and pulls out a disk and runs for it, they can't get the data off the disk because it's hardware encrypted right on the disk itself. Okay. Remember, there's in another later release we'll get the NVMe disks, and so it'll have to have NVMe adapters as an option as well. The actual sizes of the disks, they kept this really simple. We've had machines in the past that had 28 different flavors of hard disks, but they're keeping it fairly simple for this case. So the hard disks, so we've got 3 different sizes, all running at SAS at 12 gigabits a second, and they can be formatted the 8K or 512 byte blocks. Nobody's using that anymore. Everybody's running the 4K disks these days. On the solid-state drives, there's some more options here. This is where the sort of smart money goes as the price of SSDs come down, given the fact that a number off the top of my head, 10 times faster. Why wouldn't you want to boot your copy of the operating system 10 times faster and get to your data 10 times faster? So here are the options, and it's up to you what you actually want to do. Over here, we have the DWPDs. This is drive writes per day. So some drives are 2.5. So you can, if it's 3.8 terabytes of data, you can write 2.5 times that. I can't do the maths. 10 times 10 terabytes of data can be written to the disk every day, and the disk will last. I think the number is like 5 years. That's off the top of my head rather than the promise. Okay, so that's nice and simple. You choose your technology, you choose your size, and the prices per gigabyte for the hard disks are all about the same. The prices for the solid-state drives are all round about the same as well, so there's no problem there. You pay your money and takes your choice. Now, how do we actually plumb these in? Well, in slot 5 in the machine, remember here's 1, 2, and there's 3, 4, 5 above each other in here, so it's the lower high-profile disk, high-profile adapter. We put in there the 930018i, and then you cable that in. We have to have the disk bay in here, and we have up to 8 drives in that. It's the actual part number of the drive, but these little numbers in here are the lengths of the cables, so we can make sure that we get the right cables delivered to do that, so we don't have to loop cables around and try and lose them inside the box. And here's an example. Then we'd have 8 drives off that one disk adapter, and the others would have the 2 fillers to make sure the airflow is working properly inside the machine. If you want more, then we could have one 16i and one 8i adapter in here. This one covers 1 bay, and this guy's got twice the number of ports on the back, so it's actually going to cover these 2 bays, and we have different length cables in here for those 2 solutions. Again, they're keeping it nice and simple, so we don't have lots of questions of what you actually want to do. Now, this is a complicated diagram in here. I'm going to walk you around it. Here's our Power9 chips down here, and we can see this is the speed we're running, 16 gigabits a second, 4 byte wide, bus between the two machines. That's fairly standard these days. At the back of the machine, we have the slots 1, 2, 3, 4, 5, etc. But we also have some other bits of technology sitting in here. So we have USB front and rear. We have RJ45s, 1 gigabit Ethernet adapters, and we have a management port that connects to the BMC. And these are connected via other ways around in here. Some of these adapter slots, you'll notice the G4 ones coming in red and go straight into the G4 port inside the Power9 processor, but some of them are connected in black in here. That connects to a hub. This is I tend to call it a Plex, and it's like lower technology, but a USB hub. You know, you plug that into your laptop, and then you have 4 plugs to plug into that one that goes into your laptop. So this means that they're running at slower speed, these black ones in here, because they're going through this multiplex. Now there is one little odd feature in here, that this is generation 3 16-way, so that's running at half the speed of this guy, but that plugs into this Broadcom Plex chip, but this is a G3 Plex chip in here, and it's going up into a G4 × 8 speed. So the speed coming out of the processor is lower than the speed in this slot. We can put a G3 16 card in here, it will send the data up in here, but if it's going full speed, then there's a little bit of a bottleneck in here as it comes in, and this has been fixed in a later generation when we have faster versions of these chips. They're just not available at the moment, so we can't actually put them in. In here we can see there's another G4 16, and there's a G4 8 in here that's coming into this chip as well, and there's the final one in here. This is a G3 × 8 in here, full height adapter slot. So the ones in red are going to be faster than the ones in black. Having said that, the ones in black are still fast. They were as fast as you could possibly get in a previous generation of computer. And you'll see that this is just about mirrored, except in here we've got the A speed in here, which is the BMC, the service processor, and it's running the VGA and wow, an RS-232 port. There's a blast from the past. And yeah, that's it. So that's describing what you get in each of these slots, and this is why there's adapter slot placement rules to make sure the high-speed adapters go into the high-speed slots. We'll come back to that in a couple of slides. We can see in here the OpenCAP is already built in here. Again, we'll have to check the device drivers and go through testing and make those fully available for the right adapters later on. You tend to put those adapters into a slot to get their electricity power, and you have a direct cable that goes from the back of the adapter into this little plug that plugs into the Power9 to give you the CAPI interface running at 25 gigabytes a second. That gives it the bandwidth. That actually lets these CAPI devices talk straight into memory as if it was another Power9 chip actually sitting out on the adapter. Right, enough about that, Chuck. We'll probably come back to him here. I just noted up here, this is like an M2, this is an NVMe port, which we haven't got available at the moment, but we will do later on. Right, perhaps you're into fiber channel. We're not talking about typically. People don't use fiber channel for AI and high performance computing. It tends to be more the database sort of people, but you could be keeping your AI data out on a fiber channel disk array or something. So we have 16 gigabits and 32 gigabits. Nothing terribly exciting about that. They don't need too much PCIe bandwidth, so they're Gen 3 × 8, and we can go full speed with that. Remember, these only have 2 ports. If these had 4 ports, that probably wouldn't be enough to maintain the bandwidth. But that's fine for a standard fiber channel port. Now we're talking about Mellanox. This is what people in high-performance computing and AI typically want to use. Very, very high-speed interconnect for a cluster of machines with fairly expensive disks, networks, to be honest. So we have 3 options in here. I don't even know what half of these things mean. Well, you can see we're running at 100 gigabits a second, and we definitely need a Gen 4 up in here. times 16, you'll see that this is 2 ports. If it's the 1 port model, then we can get by with the Gen 3 16 to do that. Now these the two port adapters have to fit. So you can see we've only got low profile adapters. There's no high profile, full height versions available at the moment. So they want to go into the ×4 16 lane slots. So that limits the number of slots that they can actually put into in GA1. Let me just go forward. Yes, okay. Let's go backwards if I can hit the right button. Why did I say there's only 2 slots that those can go into? If we look in here, here's a Gen 4 16, and here's a Gen 4 16. But these ones in here are the full height adapters on this side. This is the only low profile adapter slot. So it's this one and this one that those Mellanox 2-port adapters would have to go into. Unfortunately, that's also the ports you want to put your GPUs into. We'll come to that on the next slide. That's the Mellanox networks. We have some other network cards in here for your 10 gigabit networks. At the moment, there's no 25 or 40 gigabit networks available. You could put 10 gigabytes in 4 ports, couldn't you, to actually build up to 40 gigabits a second if you wanted to. There's a nice cheap and cheerful guy down here that Gen 1 can run off that. It's just got 4 1 gigabit ports to get these sort of general run-of-the-mill networking bandwidth. Okay, adapter slots for acceleration. Here's the NVIDIA. It's called a T4 or Tesla T4 adapter. Unlike the AC922, where those go on the plane and directly attached to the processors, these are an adapter, a regular PCIe adapter with a graphics engine on in here, so we can run at the slower speed of a PCIe adapter will let you get to. They want Gen 3 16s as the minimum. These have 16 gigabytes of memory. There are some adapters that can have 32, but it's not available in here. Here's the Tesla G4 details in here. They say here the Gen 3 16, that works fine in a Gen 4 16 slot. The adapter and the slot will negotiate what speed, and they'll go down to the highest speed that they can both go to. Here's the 300 watts then for this adapter. Quite a lot for an adapter, but that's okay. Notice if you're using the AC922, you've got a V100 processor in here, and that's taking 300 watts. And this amount of power and heat that it's going to generate limits what we can actually put into the AC922 for like disks and adapters. So this is built to put in the maximum number of those adapters. In fact, the AC922 doesn't make an awful lot of sense unless you're using the GPUs. It only has 2 disks and 4 adapter slots. It's not that good as a general purpose machine and not recommended for that purpose. So where do we put those into the machine if we want to get to 6 adapters? Here are the slots. The preferred slots are these yellow numbers in here. So we'll put 1 in here and 1 in here. This is the larger adapter, full height. Then we have to move to 3 and 4 in here. And if you want the 5th and 6th one, then they go in these slots in here. And you'll notice these red dots around in here highlighting the fact that these are half bandwidth slots. This is a ×8 slot. Remember, I covered in purple on that wiring diagram that's a bottleneck there. Now, they'll still work fine, just when you're transferring the data to and from the adapter, it's not quite as fast. The actual GPU itself doing its maths will be the same speed. Okay, yeah. Now the warning is in here. I've got a worked example in here. You may think you've got 10 adapter slots in here, so we could put 16 adapters in here for the G4 GPUs. We could put 2 Mellanox adapters in and 2 HBAs for disks in here. But these 2 Mellanox adapters want to sit in these 2 slots. So you may have to do some balancing about how many you'll trade off your GPUs for your Mellanox networks. Typically in these big clusters, they quite often run with one Mellanox card, so maybe you'll opt for the 5 GPU version in here. But there's a warning there that some clashes. Yeah, the Mellanox wants to sit in 1 and 1, 2, 3, 4, 5, 6 slots. Okay, basically all physical things, 19-inch racks 2U. I think you might have already guessed that by looking at the pictures. Same class for the temperature and the altitude. We got maximum weight. This is fairly heavy. That would be a fully configured machine with all the adapters full of GPUs where you can, and Mellanox adapters. All the disks in the front would actually weigh quite a lot, so it's fairly dense. Oh, I mentioned the operating system before and some of the network, the other bits and pieces in here. The electrical power supply is a C20 connector, so they're ones with the sort of flat blades rather than the usual, well, we've always called them kettle leads, I'm sure you know what I mean, and they have to be 2 kilowatt power supply. Going into that, you need to be careful if you start using a regular power distribution unit and have it fully used just by IC922s, that you may be going over its maximum wattage. This machine is an open power machine, and all the parts in it, or nearly all the parts, are customable replaceable units, and they go into tier 1. This means you are expected, as a customer, to replace those parts yourself. If you want IBM to do that, then the IBM CE, the customer engineer, will turn up, but they will actually charge you for doing that, unlike our enterprise machines where IBM does that for you. If it's a tier 2, then you can replace the part if you want, or IBM will replace it at no charge. But we couldn't find anything on that list, which is a bit worrying. We looked at this list quite hard. I can't see any of those ones in purple there is the Power 8 processor itself. But then Gareth pointed out, hang on, if you change the planar, you've got to move the 2 Power 9 chips and their heatsink. So you're actually doing a Power 9 move there. So maybe that is also a CRU. Gareth found the servicing guide in there, and that includes details of how to take a Power 9 heatsink off and the chip off, and then how to put it back in again. So maybe you are meant to do that yourself as well. I was very worried about, that thermal paste that when you're doing a PC, you spread it with a credit card, don't you? And then you plop it on top and hope that it's the right thickness. With Power 9, it's like a sheet of that goo, and you just put the sheet in the right place, and then so you don't have any risks of it being too thin or too thick, and your CPUs moving about while it's in actual use. So that's all nicely sorted out, but you are expected to replace all these things yourself. If there isn't a faulty part in a second, then we'll ship you the part, and then we are expected to ship the faulty part back to IBM within 30 days. Go.
Okay, sorry. I think Gareth has answered this question in the chat window, but there was a question, do the T4 GPU cards need to be configured or installed in pairs as per the AC922? Do we have options to have 2, 4, or 6 T4 at GNU1?
You can have any number you want, up to 6.
Okay.
So you can buy them in singles, so they're not pairs. Yeah.
Okay.
Right, they're single adapters, so you can just put them in the adapter slot you want. Yeah, in the AC922, they came as a big block with 2 of them on the dome with a big heatsink and things in it.
Mm.
Okay, so yeah, we're a bit more flexible. And you might buy 2 and then say, oh, we'd like some more of that, and put 2 more in later on, if you like, as well.
Great, thank you.
Okay, coming towards the end now. This is a comparison between the IC922 and the LC922. So the LC922 is our general purpose, typically built for cloud operations or general Linux on power workloads and things. So if without the GPUs, then this is the most similar machine we have currently. And you can see in here we have with 40 CPUs instead of 44 that the LC could do. Slightly faster. In here, the amount of power the CPUs take, I don't know why people get excited about that. DDR memory, we're using more channels out of the Power 9. It's a slightly later generation of the Power 9 chip. And we have the 32 DIMMs On the motherboard, it's quite a high number of DIMMs. It's amazing how they pack this stuff in these days, where the LC922 only had 16 DIMM slots. The bandwidth is nearly double, not because of the DIMMs, just because the memory is faster. And we go up to the 2 terabytes instead of 1. The bus between the POWER9 processors is double that speed of the older machine, and instead of 12 3-inch discs, 3.5-inch discs, we have 24 2.5-inch discs. We have 2.5 over here, but that's as a 2.5-inch disc sitting in a 3.5-inch carrier. So there's only 12 can go in there. We've got more adapter slots. On a slight downside, we have to use one of those slots if we want internal disks. So the LC has an internal disk controller as a default. Of course, we've got these NVIDIA cards in here for the GPUs. The LC couldn't do that. And we got the round and square holes. Already cracked that joke. So let's move on. And we got the comparison between the IC922 and the other machine running the GPUs. And this is the air-cooled version. There's a water-cooled where we can get 2 more GPUs in it. And, quite a bit faster, 25% faster actually, in the gigahertz of the POWER9 processors. More DIMM slots. Both got 2 terabytes of data, but the AC92 has to use bigger DIMMs to get that in because it's only got 16 slots, 24 disks instead of 2. That's a major difference if you want to have lots of disk space in your machine. 4 I/O slots and 10 I/O slots, and the biggest difference is these 2 NVIDIA GPUs are different. Now the NVIDIA V100 is the Rolls-Royce GPU. The T4 has half of the number of the actual GPUs. It's 2,500 instead of 5,500 in the NVIDIA V100 in here. And we've got extension rails so we can pull the machine out while it's still in the rack and open the lid. Can't do that with an AC92. You have to pull it out and put it on a table to actually do any work inside. So here's my summary. That's as far as we're going to go. For me, you've already asked one question there. Are there anything that we should answer now, or can we go on to Gareth?
There have been some questions, but Gareth has handled most of those, I think. Are there any?
Okay, I'll stop sharing there. Gareth can grab the control.
Sure. Hold on a second. I'll pass control to Gareth.
Excellent.
There we go. Gareth, you have control.
Okay. Let's see if I can find the presentation. There we go. That looks, I think I'm showing the right one.
Yep, looks good.
Okay, good. So this section follows on from Nigel's, which we've just been seeing. We were lucky enough to receive I'm just getting a reminder to go to another meeting. Well, I don't think so. We were lucky enough to receive what we call an ESP version, which is an early support program version of one of these computers in mid-December. And basically, a picture paints 1,000 words. So there are very many pictures coming up. Some of them aren't in terribly good resolution, simply to save on the bandwidth. But if you want higher resolution pictures, feel free to reach out to me and I can get them off to you. So what is an early support program? Well, it's effectively some internal IBM beta testing. They have a number of internal and external clients. So this is something that customers are able to participate in as well. There are quite strong restrictions though. For example, you're not allowed to break any of the secrets, and we do like you to take part in a weekly feedback call and to install upgrades as and when they become available. Now for AIX programs, this can be quite time consuming, because if you get a new release of the AIX and a new release of the VIO server, you have to completely destroy your system effectively to install them because they don't include updates. It's much easier with a Linux-only system though, like this. And the idea is that it gives us an opportunity to check the shipping and the building of the products, and we get to install them into the system, into the racks. And obviously we give feedback to the development team and manufacturing team before general availability, indeed before announcement. Nigel and I are very popular with the ESP team because we are very active. We do spend a lot of work on these systems and we do give feedback, and often it's not good. The reason we are popular is because bad feedback, or feedback that things are broken, means that hopefully when we come to announce them, when they come to become generally available, the systems will be better and we get better customer satisfaction. So just some warnings. These pictures are of our ESP product, and so some of the things might be slightly different. Some of the colors might have changed, some definitely have changed, and some things might be a little bit different when you actually receive them. So you can see that the system is standard sort of sized 2U 19-inch rack. Carton came on what we call a pallet, a shipping pallet. And when you open up the box, you've got the rails along here and the power cords. Nigel mentioned that they're C20 power cords, so they're not the standard to the kettle lead ones. I'll come on to the rails again later on as well. So you take the system out of its packaging, put it onto a table. There's some good desiccant packs at the bottom. One thing that was missing with ours was any documentation at all. We didn't have any paperwork apart from the sticky labels on the side of the excuse me, on the side of the boxes. So it's a 19-inch system. You can see here that the right-hand disk bay has been populated. This is the first to be populated. If more disks were coming in, we could populate this one for this bay second, and this middle bay would be populated third. These are the disk tabs, disk release tabs. They're blue. In some of the documentation they're shown as orange, but the GA will be blue. And this is the back of the machine, which Nigel showed you as well. I've put the dimensions in here as well for your attention if you need it. Now, when we received the server, and indeed still, our NVIDIA cards were in the top two bays, and you might remember from Nigel's presentation that they should be in the middle two bays over here of the PCI slots. That doesn't really make any difference. We're not overloading the NVIDIA cards particularly at the moment, but they would have slightly higher I/O feed if they were in the middle slots. These are the Gen 4 slots, and these slots are Gen 3 up here in GA1. Also in our system, we've got a SATA adapter here, which plugs through to the disks at the front, and we've also got a 2-port Ethernet adapter in one of the low-profile slots. We were particularly impressed with the build of this computer. They've got some innovative features. It's well made. All the edges are nicely rounded, which is actually quite not necessarily always the case for an ESP machine. The nail heads which go into the slots on the rails, there are 4 of them now. Normally there would only be 3. It makes the whole thing much more stable inside the rails. And also we've got these special clips here. So if you press this blue tab at the top, you can release the lid of the computer, and then these little tabs will slide into these notches in the side of the system, which make it a much more stable and sturdy design. Under the lid, we've got this excellent service label. I've got a higher resolution image later on. There are tabs on each of the brackets at the side. There are labels around giving you information, particularly things about the weight of the computer. Maximum weight would be over 35 kilograms. It's a 2-person lift. 2 people needed to put it into the rails. It was actually quite impressive to have this quality of labeling this early on. And you can see here that underneath the lid, we've got a nicely labeled set of diagrams showing you the various different components. The DIMM slots are shown here, but there is more about the DIMM slots on another label later on. You can see that they show you the layout of the 24 disk bay front option, but there is potentially another option for 12 bays with 3.5-inch disks. These are another pair of nail heads, and I'll come back onto those later on. So lifting the lid, if you don't undo this captive bolt at the back, it'll be very hard to remove the lid. You then depress these two buttons, slide the lid back about a centimetre, I'd say, and then you can lift the cover off. Now, if the server is in the rails, if you pull it out on the rails, you can still manage to do this with it connected effectively to the rack. And Nigel's got a good movie, I think it's about 5 minutes, on taking this machine out and giving it a good service, and that's available on YouTube. So we come into the inside of the computer. If I go from the front, which is at the right hand side of the picture, we have one disk bay populated. We actually have 4 disks out of the 8. Then you move back and there's a fan cage. The fan cage itself is removable. You can take out all of these fans in one go just with these 2 blue tabs. That will give you a bit more space to get your hands in if you're going to be populating a disk plane in any of these 2 slots here, and allow you to get the cabling in. Or alternatively, you can easily remove one of the fans on an individual basis. This section here covers the CPUs and the DIMMs. You can see CPU 0 on the right, CPU 1 on the left. That might seem counterintuitive. I don't know really why they number them that way, but I'm sure there's probably an extremely good reason. But the air baffle is there. It is important. It directs the air through the heat sinks of the processors, and also these little indentations here will push the air down onto the DIMMs, which is very important. And you can see the numbering scheme of the DIMMs is labeled on there. I did say that I'd mention that again. And then as we move towards the back, at the top here, or on the left-hand side, as you look at the back, you have the 2 power supplies. This is an Ethernet adapter just inside. And then we have the 2 I/O riser cages. I note here that feature code EK30 actually is the feature code for the 2 riser cards. So don't try and order 2 EK30s. You can't do that. You can only order one of them, and it will populate with both of the slots, both of the cages there. Very good at this stage. The labeling's very good. The whole thing is very sturdy, and there are no sharp edges, and it's very tidy. And so we're looking at the front of the machine here. You can see the blue tabs for removing the disks. There's also this pull-out blank, which we assume is going to have service information on it. But on the front bracket on the left-hand side, we do have the MTMS, the machine type, model, and serial number. You can see it there. We didn't have this particular marker on there, so that's a sign that it is ESP hardware. They couldn't even get that sticker very straight, which is a bit disappointing, but there we go. So the discs, I'm sure you understand how these discs work. You just pop down the little blue tab and you can pull them out. So the 4 on the left have actually got discs in, the 4 on the right are blanks. So if you order the disk bay, you will get 8 carriers, and some of them will contain disks, or potentially all of them will contain disks, or they might just be empties. We actually have 4 960 gigabyte disks, and there are other options available. Nigel covered them in his presentation. The fillers are just very straightforward. You just squeeze these 2 tabs and you can push them in and out. Now, the important thing to note is that the disks are concurrently serviceable. That is not the same as hot swappable. If you're currently using one of the disks and you just pull it out, bad things will happen. You need to quiesce the disks, and there's instructions on how to do that in the service manuals. You've got links to that. I mentioned that the fan cage is removable in one go, and it really does come out very, very easily with your thumbs using these two blue tabs. You can pull them out. You can see that there are these they're sort of cylinders, I suppose, which lock onto these two nubs on the bottom of the cage, bottom of the rack, bottom of the chassis, I should say. You'll also see that there's this foam which stops the air going underneath, and there are these connectors which you can see are rectangular, the ones on the actual cage, but they go into sockets which are beveled. So this is a customer setup machine. I can assure you it's very nice and easy to work on this machine. These bevels will actually mean that the cage will locate very easily and snap into place. I can remember back on earlier generations like Power 5, you could take things out and it's actually very difficult to get them back in. Also worth mentioning that each of the throughs has got two different fans, one going in one direction, one going in another direction, and that means that they reduce the vibration and the noise as much as possible. So this is the air baffle. You can see the numbering of the processors and the DIMMs. These are the little recesses that push the air down over these DIMMs. So the air is forced through the fins of the processors or over the DIMMs as appropriate. Two Power9 modules. There's no option for a single Power9. And be careful though. I believe that's the part number for the heatsink. So don't think it's the one for the processor. There are these cable conduits. Whether you need them or not, they are provided because they also push the air down over the DIMMs, and they do act as a place for the cables to go, and we talk about that again in a little while. So we've moved now to the back of the computer, and this is the right side adapter riser cage. So this is the one on the far side from the processors, and you can see here that there are the three PCIe sockets. The top one has got the NVIDIA card in, and it's worth pointing out that we've got these nice edges. It looks as though at first sight you just pull it out and it just flaps there, but actually there are grooves in here and there are rails in here, which mean that the cards fit nicely into place. There's interlocking on, a little bit difficult to see, but there's some interlockings here which lock into these little keyholes, so more nail heads which lock those together. So you take out the outer one first, and then you can take out the middle one. And underneath this outer one, we've got the BMC. It's this processor or this chip here. It's an A-speed, and it's an 800 megahertz ARM chip. Fairly standard. We've been using these for some time. Now you might wonder what this little bolt is here with the green. With the blue rubber ring around it. Well, the service guide informs you that if you do need to remove the planer, you undo this bolt, and there are other bolts, and then you can use these as grab points to allow you to move the planer around. So just to give you, put you some bearings, this is the processor, and here are some of the DIMMs. So this is the middle riser cage, pretty much the same. You've got good rails and grooves for them to go into. You can see here we've got the Tesla. As I said earlier, it should be really in the middle socket. This is the SATA connector, SATA adapter with the cables coming out, which travel along into this conduit and go to the front of the computer. Very good indeed. So here are the nail heads that I mentioned earlier on the lid, and they will locate into these keyholes on top of the riser cages. And you'd also notice that I mentioned these little brackets which are in the side of the system, and there are those tabs which fit into them, so it keeps the whole thing incredibly sturdy. There's very little wobble on this computer at all when it's in the rails. Also, worth noticing that the time of day battery is very easy to access. We've had computers in the past where you had to pretty well take everything out of the computer in order to change a sort of $1, €2 through. But the time of day battery is very easy to access, easy to get your hand in as well. There's plenty of room, even for somebody who's got fairly big hands. There's also time of day batteries here. We've got the TPMD, the Trusted Platform Module device, sits there. That enables you to ensure that the operating system hasn't been tampered with, nor the firmware. And then you can see here a side view of the cable conduit. So it keeps the cable very nicely tidy out to the side and away from any of the electronics. And we've got these nail heads here, which I'm going to speak about in a moment. Now, the power supplies are very nice. They are 80+ platinum, so they are highly efficient. Some of the most efficient power supplies you'll find in the industry, they are 2 kilowatts. They are 1+1 redundant. So in other words, you can have a complete failure of one power supply. One power supply is able to power a fully populated IC922. There is no option for just one of them, though. You have to have both of them. And just a reminder, as Nigel mentioned, they are not the standard kettle leads. They are the IC20 and C19 connectors, so you should be looking for those. Nicely designed, very safe technology with the power supplies. Not much I can say really about these pictures, just wanted to highlight the quality of the labeling. You'll notice that we've got here the 2 Ethernet adapters, and this one is in a different color. This is M for management, and that is dedicated to the BMC Ethernet connection. Here we've got some USB 1 and 2. We use those for getting out to a keyboard and a mouse on the VGA screen that we use. Here is the SATA adapter, and on the right hand side you can see that we've got slot 10 would be the PCIe adapter, but there we've got the VGA port, and here is the ubiquitous serial port. We've got some lights at the back. We've got a flashing amber light for a problem. There's a green power light, and there's the blue UID light as well. And those LEDs are shown here. And Nigel's covered these in more depth than we really need to anymore. So pressing on. Something to notice on the air baffle is that there are some arrows, and that indicates that that's the part of the baffle which hooks onto some nail heads on the inside of the sides of the computer. Now, the air baffle does push the air down through the DIMMs, and we come back to that as well when we talk about servicing the fans. So here you can see the arrows on the baffle and the nail heads that they hook onto. It means that it sits in very, very neatly, and you can't get the positioning wrong. In order to remove the cable conduit, you just use these little quick release gadgets. So that's in the locked position. You move it out into this position, and then you can lift the conduit out of the server. Again, it's all covered in the service docs. Now, moving on to the rail. So basically what we did was we got the server, we took it out, we took it to pieces, we put it all back together again, having taken the photographs. And now comes the time when we actually try to put it into a computer, and we hope that it still works. Fortunately, we've never managed to break a computer before we racked it. So we took out the rails, and we were immediately impressed that the documentation was very good. And when we actually tried to put the rails into the rack, we were very, very impressed as well. Nigel and a colleague put the rails into the rack following the documentation, and it took them probably about 5 minutes, including pausing for me to take photographs. Other rail systems have taken literally over an hour to get 2 rails into a rack correctly. Now, if you can save 55 minutes on one server, that's quite nice. But if you were installing 100 of these, you would be saving yourself basically about 2 weeks, 2-man weeks worth of work. So we're very impressed with the rails. Came out of the box, everything was labeled. So you've got a B there. I know it's upside down, but that's just because of the way that the rail is. This is the A. And you can see that there's also lefts and rights. And this is very important, front as well. This is very important because it makes it easier to follow the documentation. So it's obviously easier if 2 people are doing the work. It also helps if there is something directly underneath where you're installing it, so that you can rest the rails on it. Here, you can probably make out here that the rail is resting on, it's actually, I think, a media bay. So here's the left rail at the front, and this is the right rail at the back, but it's just showing you different angles. And the 2 guys managed to get these installed in literally just a couple of minutes. Very nice little mechanism here at the front. You pull this lever out into the middle of the rack. So this is the right-hand rail. You snap the studs through the holes. Nigel mentioned that they work with either round or square holes. So you can see here, this is going through a round hole, but at the back of the pin, there is a square section, which would go through a square hole rack. So you locate the pins through, and then you swing the bracket round. Everything's nice and tidy. Once you've done that, you slide the rails out, and guess what we do next? We put the server in. So get 2 people to pick up the server, and you slide it over the top of the rails and locate the rearmost nail head first, drop it down, and then the other ones go into place, making sure that you don't miss any of the nail heads. If you've used power servers before, this will not be too strange to you, but it's nice to have the 4 nail heads. It does make everything feel very neat and tidy. And it's then a case of just releasing these safety levers, and it slides into place. Underneath the little brackets at the side here, you've got a bolt on each side to bolt it into the rack. So we've got it in the rack. We then actually went to lunch, came back. We plugged in a VGA connection. We plugged in a USB connection. This came out to a KVM at the front of the rack. And we put a couple of network cables in, one for the BMC and one for the operating system to use. We then pressed the white button and we waited. And it took us quite a long time, it must be said, to actually get the system to boot up. Partly because we didn't wait long enough, we pressed the white button again. We subsequently found out that our ESP hardware, the green LED, the power LED, isn't working, so we weren't getting the feedback that we expected. But we read the fine manual, so we got this on the actually using an electronic version because it wasn't available to us at the time. But we can see here that we should have a green light. It says the power on light stops flashing and remains on, indicating the system is powering on. And it takes about 30 seconds for the fans to slow down. So the documentation's there now, and it does work nicely. So what happens is that we go through something called host boot, and this is the BMC effectively starting up the hardware, and that brings us into something which we call putty boot. Now, sorry about the resolution of the screens, but you'll see some screenshots in a minute which are a bit cleaner. So we then decided to install an operating system using a USB stick. It was the easiest, most straightforward way of doing it. So we got hold of the ISO for Alt 7.6 version of Red Hat Linux, and we used the DD command to DD it onto a USB device. So in AIX, it would be USB MS0, and in Linux, it would be something like DevSDC or something like that, I guess. User box size 32K, and we're using the Alt version of the file, which is the one which is designed for Power9. Then we boot into putty boot, and we tell it to boot from the USB, and we have to do a little bit of work in the grub, in the Grand Unified Bootloader. If you're doing and installed from a DVD, you won't need to do this. This wasn't very well documented, but I've got some pointers to where you get the documentation for doing this. This is actually showing you a screenshot of Put-it Boot after the operating system had been installed. So at the top, we've got SDA2, that's a hard disk, and we could either boot the rescue version or the live version of the Red Hat Enterprise. And this is also showing you the USB stick that we were using. And so we would click onto, or use the cursor to point down to this particular line, to this line, and press enter in order to do the installation. And when we did that, it would bring us up to this point, which is the grub. So we've gone through phase 1 of the grub, and we then have to configure some of the parameters for the second part of the boot. So press C for a command prompt, and that brings us into here. And we type in ls-l, and we can see the user ID, the unique unit identifier of this particular USB device. 2018 1010 22 13 5500. I believe that's the date of the writing of the ISO file. You make a note of that, you press escape, and then you press E to give you an edit option, and you edit this line by adding that into the UUID into the line, and you press Control X. Now, as well as doing the ls-l there, on the previous file, you'll see that it actually gives you the UUID at that point as well. So you can do it either way. And so here's the syntax, and then you press Control X to exit, and the system will then boot up into Anaconda. Anaconda is the text-based installation menu system that you get with Red Hat. So you fill in the various configuration information that you want, so potentially the network configuration, maybe a user ID, what your time zone is, and so on, and you go through and you end up with the Linux operating system installed. We then immediately created a Yum repository from the USB stick so that we could install information later if we wanted without having the need to have the USB stick installed. That's the syntax for doing it. I don't want to dwell on that for too long. We installed the IPM iTool. Having put the Yum repository on there, we could just pull it in. And we then created the network configuration for the BMC. Now, other people might want to do it another way around. I mean, the BMC does allow you to use DHCP. It will be able to go and get an IP address from a DHCP server if you have one. Or you could use OpenBMC tools to set an IP address. And then you can actually use the BMC to have remote virtual media to enable you to, for example, have an image of an ISO on your laptop and then boot the machine that way. You'll notice here that if we're using the IPM iTool, we have to use 2 here, which is the dedicated BMC port. If you use 1, you'll get it to use one of the combined ports, which is the one of the other ports on the back of the computer. Okay, we got to a BMC screen, and I tried to log in with admin, which was the way that we used to do it on other computers, the LT92, but it's changed to root and OpenBMC. That was the same as on the AC922. That O is actually a 0, so it's 0 PEN, capital B, lowercase MC. So because I couldn't log in, I created a new user, and in this case 2 is the user ID. So 1 is root and 2 is the new user I'm adding, and 04 was the privilege that I was setting. I did that using the IPM iTool, as you can see. So you get to the GUI on the BMC. You can see things like server health is good. It's currently running. You can turn on or off the blue LED at the back here. You can go in and look at the server configuration. You can look at various things with underneath server control. For example, you get the opportunity to have a remote console. So you can power the machine on remotely, and you can power it off, and you can watch migrations and things like that remotely. So that's very, very nice. Continues to improve. Also, under server health, we've got sensors. Many of the sensors that we had were actually needed to be set. We're running with pre-GA version of the firmware, so some of the figures were a bit strange, you know, not a number high voltage and things like this, but there are lots and lots of sensors there. It's a very well monitored computer. So we also added some other repositories onto the YUM repository so that we could get more information. There are some other ones there. Again, I'm not going to go into them in detail. You can refer back to them if you need to. We put lots and lots of applications on for ESP testing. We got some help, and we put on some artificial intelligence and some cloud type things, and of course NJMON. So Andrew Laidlaw was very helpful, putting on some artificial intelligence testing stuff, and he enabled us to start flexing the Teslas. And so you can see here we've got lots and lots of processors. We've got 160 logical processors because we've got 2 times 20 CPUs, each acting at with 4 SMT4. You can see that we've got 4 disks in here. We've got SDA, SDB, SDC, and SDD. SD, I think we've also got somewhere. We've got yeah, here we go. SDE is actually the 8 GB USB disk. So everything seems to be working nicely down here. You can see that the latest version of NMON also allows us to track the work of the NVIDIA GPUs. That's all working nicely. And here, just to show off screen that NMON and NJMON, great at monitoring your computer. Okay, some documentation. The 6 Ps, proper preparation prevents particularly poor performance. So please give yourself the best chance. Go off and look at the documentation. This is the landing page, which Nigel was mentioning. Here are the PDF documents, and these are the ones that I would particularly recommend that you get beforehand. The planning, installation, and servicing guides. Get those locally stored on your system. And this is something that IBM's documentation doesn't really point you at. This is how to install Linux onto these servers. It talks about the AC92 and the LC922, but this talks about installing Linux onto the server. It works well with the IC92 as well, and it shows you how to do it with virtual media, or installing it with a network boot, or just using a USB device. That's where I got my syntax from for the things that I showed you earlier. So, a few gotchas. Get the installation documentation beforehand. It does take a while to power on. Now, we had pre-GA hardware. We didn't have any green light here. But even with GA hardware, it will take a while to power on, so do be patient. But that's the system. It works very well. Now, fan replacement, you can concurrently replace the disks, as I mentioned earlier. You can concurrently hot replace the power supplies at the back. But the fans, we were told that they are concurrently replaceable, but the service guide does say power off first. And if you do take the lid off when it's running, Nigel will assure you that it gets very loud very quickly. So we do advise you to power off if you're replacing the fans. Apart from that, no other concurrently replaceable devices. So that's the team who installed it. It's actually physically installed behind this VGA screen. Jyoti, are there any questions that we need to cover before my summary slide?
No, I think Nigel handled a couple already, so
good.
I don't see any outstanding questions. Just a couple of comments, but
all the questions are outstanding.
They are indeed. With this audience, they always are. Thank you.
Okay.
So I'll leave you to cover the last bits.
So there we go. The ATS team UK think it's a very nice computer. Unfortunately, it's only on loan to us. So the good folks in Texas will want us to send it back at some stage. Everything fits together very well. It's got some really nice design features. Those nail heads internally and externally are very useful. It's very sturdy in the rails, and we love it. We think it's a great computer. So, thanks for listening.
Great. Thank you so much, Nigel and Gareth, both of you, for taking us through all of that with the IC922. If you do have any questions, I'm talking to the participants now. If you have any questions, please add them to the chat window, and we'll stay on for a couple of minutes to answer those. Other than that, let me just tell you quickly about the next session while you're thinking of questions. So the next session is on the 25th of March, and it will be at 10 a.m. UK time. I will send information to all subscribers, and I'll also add it to the PowerVug info page on IBM Support, the new home. And the session is going to be Chris Gibson sharing his experience of AIX live update, so best practice session for AIX live update. So I hope that you can join us on that session. In the meantime, I'm going to stop the recording and we'll stay on for a couple of minutes. So type away your questions as you think of them. Thank you all for joining.